Alright, so here we're going to talk about conversion. So before we get into that, we need to have a better understanding about the size of angles in radians versus in degrees. And let me back up. The size of the angle doesn't change, but just the units can give a different perspective. So how many whole radians are in one revolution of a circle? And keep in mind I'm saying whole numbers, not just total radians. So we know that it's 2 pi radians, but what is that in whole numbers? We talked about that a minute ago. So I want you to pause the video and answer this question, how many whole radians, and then how many degrees are in one revolution of a circle as well. So pause, unpause when you're ready to discuss. Alright, so hopefully you came up with that it's 6, right? And it's not exact, right? There's actually more, because 2 pi is approximately 6.28, but out of whole numbers, well, the whole number is 6, right? How many degrees? One revolution is 360. So there's 360 degrees in one revolution. Okay, why are we talking about this? So the next question is, which is bigger, 1 radian or 1 degree, and approximately how much bigger? So again, I want you to try and think about this on your own. Pause the video, think about it, unpause when you're ready to discuss. Okay, so hopefully you came up with that 1 radian is actually much larger than 1 degree. And how we're figuring that out is if there's approximately, again it's not exact, approximately 6 radians in one complete revolution, and there's 360 degrees in one complete revolution, well, there's a lot more degrees, so they have to be smaller in the same size thing, right? And then approximately how much smaller or bigger? Well, 360 divided by 6 is 60, right? So 1 radian is close to 60 degrees. It's actually closer to 57 degrees, but we can say, just for rough approximations, it's close to 60 degrees. That helps you get a better visual when you're trying to think in your head about, like, what is 1 radian? What is 2 radians? And we can say, okay, well, that's approximately 60 degrees. 2 radians is close to 120 degrees. Another thing I want to point out real quick, units. So notice that when we have degrees, we are always going to have the degree symbol. When we have radians, there is no symbol or notation for radians. So anytime you see something like theta equals 2, if there is no degree symbol, then it is implied that this is radians. Okay, so you have to be told or have a degree symbol in order for it to be degrees. Otherwise, it is implied that it's radians. All right, moving on. Conversion. So how do we actually convert? Well, we just talked about relationships between radians and degrees. We know that 360 degrees is 2 pi radians, right? Because we know that 360 degrees is 1 time around a circle. 2 pi is 1 time around a circle in radians. So to simplify this a little bit, if we just divide both sides by 2, we also know that 180 degrees is pi radians. And so this is how we convert. Now, depending on what science classes you've taken, or actually just even from grade school when you learn to convert feet to inches or feet to yards or something like that, we can convert from radians to degrees or degrees to radians. So to convert from degrees to radians, we are going to multiply the degrees by pi over 180. And again, this is the same type of conversion that you would do for if you have inches and you want to convert it to feet or something like that, where you always multiply by what you want. So we want radians, and you divide by what you have. So we divide by degrees. If you've taken a chemistry class, you have called this factor labeling. Some of you may not have taken chemistry yet, so if you haven't, that's okay. But it's just converting the measures. So we're going to do this for a few of these, and then you're going to try a few on your own as well. So convert the following degrees to radians, leave as exact values, and round to 3 decimal places. So we're going to have 2 different answers. So if I have 45 degrees and I multiply by pi over 180, well, I can reduce this. So 45 over 180 is going to be 1/4. So this becomes pi over 4 radians. So that is the exact value reduced. And then if I take that same thing and I type it into my calculator, pi over 4, and I get, this is approximately 0.785. That's 3 decimal places, radians. So pi fourths is approximately 0.785. You can call this 1/4 pi or pi fourths. You will hear me refer to it as pi fourths, but if you say 1/4 pi, that's the same thing. Any questions? Okay, next one. Same thing, 70 degrees, so I'm going to do times pi over 180. And then I'm going to use my calculator or my brain to help me reduce this. And I know that they both have a factor of 10, so I can think of this as 7 pi over 18. So that would be my exact value. And now if I'm going to type this into my calculator to get the decimal equivalent, this is approximately 1.222 radians. And we should know, right, we just talked about 60 degrees is approximately 1 radian, so 70 degrees should be a little bit bigger than 1, right? 45 degrees should be a little bit less than 1. 180 degrees. We actually just talked about what this is, so I know that this is pi, right? We talked about that. That's actually how we're doing our conversion up here. And we know that pi is 3.14, 159, and so on, so we can say 3.142. I want you to try and do 585 degrees and 301 degrees. And again, both have the exact value reduced and the decimal equivalent. So pause the video, try that, unpause when you're ready to check. Alright, so hopefully you got with 585 degrees multiplied by pi over 180, that's 13 pi fourths, or 13 pi over 4. This is approximately 10.210 radians. Now we're going to come back to that one in a second. For the 301 degrees, this does not reduce, so it's just 301 pi over 180, which is approximately 5.253 radians. This is radians as well, that's just the exact value. Now one thing I want to point out, if you are confused, a way to help yourself out with these and reducing the fractions. So for instance, on my calculator, and maybe most of you know how to do this, maybe you don't, but if I type in, so 585 over 180, I hit enter, I get this decimal, and then if I hit math and fraction, I get 13 over 4, and so that's how I knew that this is going to become 13 pi over 4, because when I typed it into my calculator, I ignored the pi. I know typing pi into my calculator is just going to give me a decimal. Okay, so now back to this though, I want to point out, so 585 degrees, that is more than one time around a circle, right? And so we might ask ourselves, well, how is that possible? Well, think about, again, if you go back to, if you're familiar with any sports or activities where you spin, you can spin more than one time. And so this is true with angles. We can have more than one revolution. And so what does that look like? And so I've drawn this here in standard form, so 585 degrees or 13 pi fourths radians. Here would be my initial side, and then I'm going to rotate counterclockwise. I rotate once, and then I'm going to continue on until I get to here, and this would be 585 degrees or 13 pi fourths, where here is my initial side and here is my terminal side in the third quadrant. We'll learn a little bit more about this coming up, but keep in mind, so we're rotating counterclockwise, starting with our initial side on the positive side of the x-axis, and we rotate counterclockwise because that is the direction in which the quadrants go, right? So this is our standard form of an angle. Alright, so now we're going to practice converting from radians to degrees, and so similar to before, we multiply by what we want, which is degrees, and we divide by what we have, which is radians. And we know the relationship between radians and degrees, or then the simplest relationship that is still nice, I guess. I don't like the word nice, but 180 degrees is equivalent to pi radians. So if I have 1 radian and I want to convert that into degrees, we can multiply by 180 degrees over pi, and that is actually our answer if we leave it as exact values reduced, so 180 degrees over pi. We can type that into our calculator, And this is where we can see exactly that, or not exactly because it's still going to be rounded. This is 57.296 degrees. Alright, I want you to try and do the rest on your own. So pause the video, convert from radians to degrees, unpause when you're ready to check. And remember, have fun. Alright, so here, 60 radians. Like, think about that. That's actually going to be a pretty big angle, or a lot of rotations, right? So if I multiply that by 180 over pi, I get 10,800 over pi degrees, which is approximately 3,437.747 degrees as well. Sorry, I should have a degree symbol there. So again, a lot of rotations with that one. 16 pi thirds. So I did that down here. I multiply by 180 over pi. The pi is reduced. I can reduce the 180 and the 3, and that's just 960 degrees. So that's both the rounded and the exact value. And I apologize, I skipped 3 pi fourths. So 3 pi fourths times 180 over pi, similar sort of thing, where this actually just comes out to be an exact value. The pi is reduced, 180 divides by 4, and we just get 135, or I'm sorry, 180 reduces with 4. And then the last one, 24 pi thirteenths. So here I multiply by 180 over pi, the pi is reduced, type this into my calculator, I get 332.308 degrees. If I write that as an exact value, and again I'm using my calculator to help me with this, I get 4,320 over 13 degrees. Alright, so the last thing we're going to look at in this video is the relationship, going back to our definition of radians, and that is the relationship between arc length, radius, and the central angle. So here is a typical application problem of this relationship. Given an arc length of 25 feet, so that's my arc length, and a radius of 17 feet, find the central angle in both radians and in degrees. Now remember, our relationship, theta equals s over r, where s is the arc length, r is the radius, and theta is the central angle. This relationship is only true in radians. So, if I want to find my central angle in radians, I know that 25 over 17 is my central angle in radians, right? That was pretty easy. To find it in degrees, I just need to convert that answer to degrees. So 25 pi, sorry, said it and I wrote it wrong. So 25 over 17 times 180 over pi, and we can do both the exact values, so 25 times 180 divided by 17, and this is going to be 4500 over 17 pi degrees, so that would be the exact value. And if we type that into our calculator for a decimal approximation, this is going to be 84.258 degrees. Now, one thing I would warn you about, be very careful when typing something like this into your calculator. A lot of times, if we just type in 4,500 divided by 17 pi, your calculator is going to do 4,500 divided by 17 and then multiply that answer by pi. So if you're going to type this whole thing into your calculator as it is, make sure to put the 17 pi in parentheses. Any questions? Okay, last thing, real quick, sorry. Make sure before we do this also that these were in the same units as well. If those were not both in feet, we would need to convert one or the other into the same units. Okay? Moving on. Oh, and I'm sorry, one last thing I wanted to point out also, sorry, just a visual of this. So when we say arc length and central angle, that means it's something like this, where we've got, this is a big arc, but the arc length that we're talking about is this piece right here. This is 25, this is definitely not to scale, this is 17, and this is our angle, theta. There we go. Now moving on.